Happy Monday to you. Okay, so just kind of a week at a glance here. Today is kind of really the last day of new material. We're gonna talk about the quotient rule today and kind of focus on that today. We're going to continue to focus on the quotient rule tomorrow. So our essential question is, how do we calculate derivative of quotients? I did just change one word in the essential question. And so just to kind of talk about the quotient rule here, we know that we can remember the top by remembering the phrase rho d pi minus pi rho. Helps us remember what goes in the top. The D just stands for derivative, right? Fine. So rho means grab V. D high means come up here and differentiate that and put that there. But if you notice, this numerator is the same as the product rule. Does that make sense? It's just got a minus instead of plus. Right? We still have U times V, I just write it backwards, and UV. So if you can just remember that those are the same, it helps you remember both of them. So we also talked, we learned about symbolically representing the quotient rule for tabular and graphical applications, just like we did with the product rule. We learned that when using the quotient rule, it's very convenient to think of the number as some generic function u in terms of x. And so that gets into writing it symbolically, and same with v in terms of x. And we also learned with some of the examples that using brackets in the expression is a really good organizational strategy. On the word wall, I've got the derivative rules there with the product and quotient rules right above Matt there at the end. But they're also up there as well. Okay, so this is the same thing we looked at last week. There's function f, there's function g, it's graphical. I converted the data on the graph into a table, and last week I multiplied them together. This week I'm dividing f by g. And so here's all of these quotients that we get. And I can do the same thing as I did last week. If I want to focus on x equals 8, I can graph all those quotients. So, you know, this is 6/11ths right here. And this next one is, I don't know, I can't remember what it was anywhere. But then I can fit this curve, I can fit this these points to a curve. I had to do a little approximation there, a little curve modeling. But if I get that, that's a polynomial, so it's all powers of x. If I get that function, then I can do a power rule and get the derivative and evaluate it at 8. And so when I evaluate this at 8 and find the derivative, I find that the slope of the tangent line is 1.75, which is what you calculated in the notes. So knowing the quotient rule is a much quicker way of getting that point, that slope at 8, that derivative at 8, rather than trying to convert all of the data you have into a different function. Questions about that? Okay. So here's your challenge today. You're going to do the quotient rule on 4x squared divided by natural log of x. So work on that one for a couple of minutes. Call the top U, call the bottom V. In Blackboard, there's some videos that students made with organizers for both the product and the quotient rule that are pretty effective. At least they found them effective. So you might want to take a look at those organizers. Then go ahead and calculate the derivative when the derivative of function f when the value of x equals e. I'm going to give you the answer right away. The answer is 4e, so you know you've done it correctly. After you've gone through, if you get 4e, you're good to go. You can move on to your topic questions now. And I've got circuit in there too. That's just extra practice again.
Oh, it just says sports.
Yeah.
Oh, does yours say 4x3?
Yes, ma'am.
Oh,
Yeah.
no,
Not cool.
not cool at all.
It's not nice.
Let's see, low, D, high. Nope, it should be 4x squared. High, D, low. Yep, should be x squared. Yep, change it in your notes. Should be x squared. Sorry about that. So it's wrong on the sheet. Wrong in the notes. I can change that while you're working on that. Notes, 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 notes. Quotient